Hello and welcome to the CytoCave live recorded demo. This is an isomap coordinate system representation of the ProCan data set, protein interaction data set. The connections are from the string uh, protein interaction database. So it's got two viewports, left and right. They're independently uh, navigable. Up here, you can select the coordinate system. I've pre-computed 1, 2, 3 coordinate systems, isomap, random trees, and t-SNE. And then there are 3 sunflowers and 4 sunflowers. So that was isomap we saw. There's the random forest, or random trees. And now this is t-SNE. Down here you can adjust the size of the glyphs. And you can zoom in. You can uncheck these locks, and that'll allow the glyphs to be resized independently of each other. And turn the skybox off. So we can, so now we have the t-SNE coordinate system on the left, and you can really see some really good definition here. You can unlock the color coding selector. So the default is the degree range. You can see that the color, well, if it's t-SNE color coding and t-SNE layout, then the clusters will make sense. Because the clusters are computed from the module membership of like the proximity of the nodes and the layout. So you can see here there's a large central blue cluster with a red periphery and some yellow spots over there. So those yellow spots can be inspected. You can see which genes those are. So you can do some gene or which protein of interest discovery on those. So you can click on one of these. So that one was clicked. Now it's unclicked. And you can see its network. Some of them have a high degree. Others have not so high degree. You can sync up the displays so there's the same angle. So now you're seeing t-SNE on the left and isomap on the right with the degree. So you can click on some of these nodes and see which ones appear on the right, and you can note their isomap coordinates and their degree. You try to look for patterns there. You can make the color, the entire color regions disappear. You can toggle all of them, and then you can make certain ones appear bright. Like that region just appeared bright over a translucent background. You can also make them disappear. You can select the Louvain community, the Louvain community partitioning. You can see how the TSNE modules and Louvain communities overlap. So when you zoom out in the TSNE representation, you can see these dots there. So this cloud here, that's the drugs. So the drugs are represented as, well, the drugs are represented as these boxes. And so the boxes, when you click on them, well, you have to adjust the threshold. You click on them, they'll connect to each other, and they'll connect to the genes. You can turn on isolateral and contralateral and uh, have different thresholds for cross group connection, intergroup and intragroup connections. You can set up different thresholds for that. So you can browse different gene or different drugs of interest, and let's see, let's make these boxes a little smaller. Change this. No, let's make them small. You can adjust the sizes. You can adjust the opacity. And zoom in on the drugs. Change this to Louvain. So you can see by the random distribution that Louvain and TSNE for the drug interactions don't overlap very well. The isomap and TSNE overlaps a little better. There's AZD, there's a drug. We can click on an interesting drug and see which connections it makes to the proteins. These are the proteins that are affected by the drug, directly or indirectly. AZD7762. So you can see that, we'll make the box here a little bigger. So this is the isomap presentation, and the box is in the middle of this one. So you can see from all the edges emanating from this box which proteins are affected by AZD7767. I'll make the spheres a little bigger. So let's find, well, that's a drug. It's a drug way out there. Looks like this is an outlier that's affected. Well, that's NAP58. You can see all of the proteins that interact with it. Oops. So looks like this one in the blue module, LSM4, and you can click on that and see which proteins interact with it, and also which drugs interact with it, because you can toggle it, and some edges will appear over here. Looks like this drug also PDI 7306. So you can follow that chain around. There's also a search box. You can I can't think of any drugs right now, or genes. I don't know. Um, okay, I can't think of anything else to show you at this point. Looks like you've seen everything. Oh, there's a label. I just click on the or press the L key on the keyboard, and it turns on the label that follows the mouse around. It's kind of experimental. It's really useful for VR. There's enter VR buttons over here. That'll, if you have a web XR compatible headset, it'll turn that on. This can get annoying. It's still experimental. Sometimes it gets over uh, obscured by other nodes. But in VR, they don't have any of these panels, so there's no info panel, so it's the only way to see any info in VR. We'll turn that off. So, and then when you turn it off, it just stays on the last one it hit, so it just stops reacting to the mouse. So that can be useful for labeling a node and just getting a closer look and just kind of keeping a tab on it. So yeah, that's it. Thanks for watching. Show you the sunflower a little bit more. Let's see the sunflowers. Sunflowers. So that's the random trees sunflower. It's static because you're crossing coloring and coordinates. If you have the same ones, then it'll have so you can see it'll have the coherent coloring. The sunflower will tell you if you know how overlapping certain module partitionings are, because you'll see a color mosaic if they're not overlapping, and you'll see some patterns if they're overlapping. All right, well, now that's really it. Thanks for watching.